So hello everyone, today we have this new product in the line which is fully programmed by me in the C programming language. So I hope you enjoy my work. This is digital display at this point. Today we discuss about how to solve the problem by scrolling two lines parallels. So we have faced some problems by scrolling these two lines. So today we see how to program it so that two lines are parallelly scroll side by side. So today we see in this video that how this works and what type of hardware I use, what type of microcontroller I used in this project. So I hope you enjoy my work. This is the real programming channel. So whenever you have to see the programming language, how does it works, you can contact my numbers at any time. So let's hope you enjoy my work. So let's get started the video. So here's, you can see now on your screen how this project is looks like. So here's the power cord, you can connect battery in it so that you can make it handy. So let's press the power button from here and you can see it's lighted up, and you can see this. First it boots up the program and then start running. You can see in this LCD, this is 16:2 LCD which is Hitachi HD. So as you can see, first it put the all the alphabets and then it scrolls down. Here you can see this lamination is for dust free operations of LCD. So now it's ready to scroll the message. So here you can see my mobile number and my channel contacts. So in this video right now we're starting the programming, the hardware, all in a single video. So let's get started programming. So as you can see on this, as we play the simulation, then you can see how this box reacts and how does the LCD show my name. The program is running in the microcontroller. I zoomed in to LCD. Let's see how does it works in simulation mode. So we use this type of CAD softwares here for actual programming, so that we do not use hardware at first, so that everything runs perfectly on the real hardware. So we use this type of CAD softwares here. So this is computer aided designs for electronics and communication engineers. So we use Proteus ISS for the designing purposes and Keel Microvision 4 for programming purposes. As you can see, this is running my program side by two parallel lines. In the first programs we use single line coding, but we have to needed that two lines parallel programming. So in this video we see how does these two lines scroll parallelly for this project. We use this type of coding in our next future projects, in the digital scanners and fingerprints and scanners on doors, in houses, security systems. So all these experiments are helpful for my future work. So let's see the program and the hex files where I have to save. So in this we have Keel Microvision 4, which is here. Here we have Keel Microvision 5. So we have the code right down here. You can see as ramit LCD interfacing.c. So here is the full program that we have. As I make a closer look at this point, as you can see here, it's a program. As I scroll it down, so here's the program I can write on my screen. As I make rebuild targets, as you can see there is 0 errors and 0 warnings. So everything we have to run it on the simulator. and put the hex files in this microcontroller. So let's see the programming. So here you can see it's the actual programming, the bits we had. So you can make changes anytime at your point. If you helpful, please comment below the video link. So here we use this type of microcontroller. So today we program this microcontroller. So let's see how this program works. We boot it up by a programmer called. So at first we present the basic domains here. It's hash include, which is hash include register 52.h, which means we use the microcontroller register 52.h. Then we present the pin functions, which is single bit, that is reset. We have to use port 3x2, and single bit we also used write pin here, which is port 3x3, but which is port number third pin of the port 3. And again it's a single bit. We use the enable pin here from port 3 by using the bit number 4. So we present the delay, which is used here, that is unsigned int, which is 16-bit. And we also use the void command, which is unsigned character here. So another thing, we have the second data function, which is void data, that is unsigned character. So we had unsigned values like minus to plus, so we used void main, which is the starting of our main program. We use the curly braces here. Next the real programming starts, which is unsigned character. Here we have the square brackets, and here we have our name line here, which is ramit engineering works, and comma starts, and mobile number it's 6280676472. and here it's a single line, and it's another line we have the unsigned, it's unsigned character 1, it's alphabetic 1 or numerical 1 we use here. So the braces start, it's a channel on YouTube, it's ramit dhiman. So here you can see the program. It's now we have to program the delay function and the command routine. It's unsigned int I, j, k. We use three variables here, which is, now we use the command, the first line of the LCD, and again command we used the first line skipping, which is the first row, first alphabet, and then starting the second one with the command which have to enable the LCD, which is 0 type E. It's third of the line, and again we use the command 0 cross AT. Here you can use the LCD table from the data sheet so that you can confirm that the values are same as present in the data sheet. So for now we use the looping. So for here we use the for loop. It's I is equal to 0, which is character, and the braces I, which is not equal to 0, and then I plus plus. Again we have the data function here, which is data character braces, square braces I, and semicolon from, and the data, it's command for the next line of this column, it's 0 cross C naught. Again we have started the for loop, which is j is equal to 0 character 1 curly braces bracket, which is not equal to 0, it's j plus plus. So here curly braces starts its command line, it's 0 cross, we use 0 for presenting the value. So here you can see it's the half program, and the next step we had the data, which is character 1, it's j braces close. So with the for loop we also use the while loop, while for forever 1. So the curly braces starts. So for the value for k is equal to 0, k is less than 50, then we use the k plus plus, we can increment, and then we use the command 0 cross AT for the below line for parallel programming, and the program curly braces closed. Then we have the delay routine here, void delay, unsigned int t. So curly braces starts, which is unsigned int I and j semicolon. We enable the LCD for the operation to write on this, and then we have the for loop for I is equal to 0, I is less than t, I plus plus. Then for j is equal to 0, z we have using 1275 for some delay, and then j plus plus. Then have enable is equal to 0 for reading, and then we close these curly braces. Then we have the void command routine, that is unsigned character ch then the braces, curly braces start, then reset is equal to 0, and it right is equal to also 0. Port 2, the port 2 has the character we have shown here. We have the delay of 50 milliseconds for each character. Then we curly braces close, and then we have the void data function here. Void data, which is unsigned, that is of 16-bit, unsigned character ch, and then we have curly braces. We have reset function is equal to 1 for writing, and for writing is equal to 0 for reading operations. Port 2 is equal to character ch, delay of 50 millisecond again. Then we have close the delay routine or data routine, and the curly braces close. Here it's the end of the program. So for the 2 lines scrolling, we have this type of program. As you can see, program for parallel line scrolling for 16:2 LCD. You can note this program for scrolling the 2 lines. Here you can see as we used to make the closer look. Here you can see the program. So here you can see the program. Here we had here we have the 50 to 55 lines. So we make the hex file from rebuilding targets. Here you can see there is no errors and warnings. We had hex files, and we run it from here, and we now run it and see how does it works. So right now we opening up the project files. So here it's my project here. As you can see, we run the project side by side on this box here, and on the screen of my monitor, on my screen of my laptop. As I press the button, you can see the things happens. Here it's opening the project. Here you can see the hex file here. We run the project here. Here you can see the LCD. We zoom it on it. So here I press the start button, and also we provide the power button here. As you can see here how these things works in real life and on computers, how world uses these technologies to program the microcontrollers. So it's the beginning. We start this type of projects from now. Please ensure you have to subscribe my channel. So here you can see what we have on my simulator and what's run on the actual system. So it's a demo video here for programming enthusiasts. I hope you enjoy. So I think simulated delay is more than the real actual world. So I think it's the possibility of crystal frequency. So as you can see here, the overall project. So we use this type of file series and programming skills in my next future projects. We can connect the relays and automate the house systems, machineries, the stepper motors, opto isolators. So it's the thing. We're using the Proteus software for this. It's the best software for this type of works. Thank you very much. It's Ramit Dhiman from Ramit Engineering Works.